Hey guys, it's Barris. Last time for me for a while. Thank God. So today we're talking about the discriminant. B squared minus 4ac. You should recognize that from the quadratic formula. It's the thing that's underneath the radical. And whatever's underneath the radical allows us to discriminate between the different kinds of roots. Okay? So when you discriminate between the kinds of roots, you don't actually have to find the roots. It's pretty darned exciting. All you have to figure out is that b squared minus 4ac. So let's do it. So the first one that we're going to look at is this one. And what's going to happen is the discriminant is going to be a positive perfect square. So that's the first possibility. Now we're going to say what happens when it's a positive perfect square. What happens is the graph looks like this. So this is the quadratic equation right here. And if you were to graph it with a y equals, the graph would look like this. And it would hit in two perfect spots. And it's going to turn out to be nice, wonderful whole numbers or fractions. Nice, not irrational numbers. So this number, if you do the math here, turns out to be 16. If you take the square root of 16, it's 4. So that's not a radical anymore. So no matter what I get the answers are, which if you do this correctly, it's -1 and -5. So remember when you do these, you do -6 plus 4 over 2. Do the top and divided by the bottom. And then you would do -6 minus 4, which is -10, and so on. So when you do this, you get -1, -5 are your nice perfect roots. So what we call these, when it's a positive perfect square, the roots are real, rational, and unequal. Unequal just means that there are two of them. Okay, so another way we also say it is two rational roots. We say it two different ways. So real, rational, unequal, RRU, or two rational roots. Two different ways we kind of go about that. So the second possibility, if the thing underneath the radical, so the discriminant, is not a perfect square. So remember with this one, if you look in here, A is 1, B is 1, C is -3. And you simply plug that in. Everything has been plugged in for you. What turns out to be underneath is 13. Make sure you do that and you get it right. Okay? So if you take the square root of 13, it's an ecky, ugly number. So the two roots are going to be ecky, ugly numbers. So if you were to look at their solutions on a graph, they would still hit twice, just like the one up here did. So these are hit twice, these hit twice, so that's where we get the two roots. Okay, but where they hit is a radical. So when you have a radical, it's an ugly number that we can't really write down. We can't just write -1 and -5. So we call them irrational. Anytime there's a radical left, anytime there's a radical left in the problem, it's considered irrational. Except if it's negative underneath, then it's imaginary. So this one, the two ways to write it are real, irrational, and unequal, or two irrational roots. So summing that up there, if we get a perfect square, so we get two possibilities, they're both positive. So if it's a perfect square, we get a rational number. So we get nice, -1, -5. If it's not a perfect square, the thing under the radical is not a perfect square, then it's irrational and ugly. Okay, but still two answers. The third possibility is that the thing under the radical is 0. And if you look over here, the difference between this one and the one up here, and the one here, this is the graph of it, it hits just once. It like goes down, hits the x-axis, and pops right back up. So that means that there's only one place it hits. And we know that's a possibility without actually without actually finding the answer if we just do the discriminant under the radical. If this discriminant, when we plug it in, turns out to be 0, then we know that it's only going to have one root, because the square root of 0 is 0. So 2 plus 0 is 2. And 2 minus 0 is 2. And 2 over 2 is 1 in this case. It'll always be a whole number or a fraction, but it'll only hit one spot. So what we say when we do that, when it's 0, we say it's real, rational, because remember there's no fraction. I mean there could be a fraction, but there's no radical left. The radical's gone because it's radical 0 is just 0. So it's rational. And this time it's equal. And since it's equal, there's also another way to write it would be one rational root. So if it's a perfect square, there's two rational roots. If it's 0, there's one rational root. And then the last possibility is the fun one. The easiest one to remember is when you do the discriminant. Remember, just as a reminder, the discriminant is b squared minus 4ac, the thing under the radical. So the rest of the stuff really isn't going to matter at all when we're just determining the nature of the roots, because we really don't have to find the answer. What we wind up getting is a negative under the radical. And you remember, anytime there's a negative under the radical, it's an imaginary solution. Okay, you could write it in both spots, but in this case, at the moment we see a negative under the radical, we know, look at that. It didn't even hit the x-axis. When it doesn't hit the x-axis, it's an imaginary root. So there's still answers, but they're imaginary. That doesn't mean they're fake. It just means they're like in another dimension almost. So two ways to write it, just imaginary roots or two imaginary roots. Just going with there's two different ways to say it. So that's it. That's the possibility. So if you're ever asked to find the nature of the roots, all you have to use is the discriminant. That's it. You don't have to find the whole quadratic formula and do all the answers and all that work. All you need to do is use b squared minus 4ac. Find your a, your b, and your c. Plug them all in. Get your answer. So in this case, the answer is 0. And now that you know that's 0, it's only one of 4 possibilities. So turn the paper over and look at those 4 possibilities. Is one of them 0? Yes. If the discriminant is 0, then the roots are real, rational, and equal. And remember, the other way of saying it is that there's two. Yeah, I did it again. Excuse me. There is one rational root. And we know that because the discriminant is 0. That's it. If you got this, got it done, fast forward, make sure you get the answers right, whatever, try these out. They're pretty straightforward, but sometimes it takes a couple minutes to click. So give it a minute, don't hurt yourself over it, just try it out. So fast forward or pause and do these. I'm going to do the next 2 out and then give you the answers to the rest. So here they are. A equals 1, B equals -4, C equals 5, B squared, remember, put that in parentheses, it matters, minus 4AC. When we do this, we get -4. Anytime it's negative, turn it over. Look at the possibilities. Anytime you have a negative under a radical, it's imaginary. The one we always remember, where it doesn't hit the x-axis. Okay, you can also say there's 2 imaginary. Next one, Uh-oh, this is not in standard form. It has to be in standard form, meaning it has to be in descending order. 2x squared plus 5x minus 3 equals 0. Squared, letter, number. Every time has to be that. So A equals 2, B equals 5, C equals negative 3. Plug it in. 5 squared minus 4A, C. Do all the math, and we get 49. 7 times 7. So that is a perfect square. Time you have a perfect square under the radical, when you take the square root, it will eliminate the radical completely. So that means this guy has to be rational. So it's real, rational, and unequal. Or with our alternative is 2 rational. If you have 2, that means they're not the same. If you have 1, they were the same. I forgot to answer this question. This one, it's imaginary because it's negative. The discriminant is negative. All right, try the rest of them. Pause it. See if you can do it. I will not step through each of these, but I will give you the answers. Okay? All right, so here are the answers. Here they are. The first one that we need to talk about is that this one was a perfect square. That's why it was real, rational, and unequal. This one here, you plug them all in, you should get 0. And that means real, rational, and equal. Zoom in a little. And or 1 rational root, because the discriminant is 0. Then we look down here, do the discriminant. You get 13. If you don't get 13, try it again. Okay? When you move this negative 5, you changed it to positive, moved it over here, and put it in the order squared, letter, number. Squared, letter, number. Okay, it's got to be in that order, so you can get the 1, 5, 3. Plug it in. You should get 13. No, wait. Yeah, you should get 13. Nice. And since it is 13, it is an irrational, because you're going to be left with a radical. If you think about it in terms of the quadratic formula, if you had a radical 13, you would know that it's going to be an irrational number. You can't get rid of that radical. Okay? Or 2 irrational. And again, it's that because it's not a perfect square. Okay? Next, this one, plug them all in, you get 0. Because the discriminant is 0, we have 1 rational root, or another way we say it is real, rational, and equal. Last one, you plug them in, it's already in standard form. You should get a negative 3. When you get that negative 3, it's a negative under the radical, which is bad, and that's an imaginary. So you do have to know each piece by heart. To sum up, if it's positive, there's 2 possibilities. Positive, 2 possibilities. 1, perfect square. That would make it rational. And all the other stuff that goes along with it. Real, rational, unequal. If it's not a perfect square, then the key word is irrational. Okay. If it's negative, that's the easiest one. Okay? If it's negative, so this should be a different heading. So first check if it's positive or negative. If it's positive, perfect square, not perfect square. Negative, imaginary. Done. Done. The last possibility is if it's 0. So 0 would mean that it's rational, but it's also equal. So just remember these key words, and that should help. Do have to have this memorized. Check for positive and negative first. Negative, it's imaginary. Positive, there's 2 possibilities. And then it's either, if it's 0, then it's just real, rational, and equal, or just 1 root. All right? It's really pretty. Have a great day. Any questions? Ask your teacher.